Good morning everyone. I am Houchin Chang, and today I will introduce our CVPR 2026 work, OMG-Bench, a new benchmark for skeleton-based online micro-hand gesture recognition. Our motivation comes from natural VR and AR interaction. Compared with large hand gestures, micro-gestures are more subtle, less tiring, and easier to perform continuously. However, existing skeleton-based gesture datasets mainly focus on macro or isolated gestures. This task is challenging because micro-gestures are subtle, fast, continuous, and highly similar across classes. To address these challenges, we introduce OMG-Bench, a high-quality annotation pipeline, and a new baseline model called HMATr. This slide shows our data collection and annotation pipeline. We use a calibrated 5-camera RGBD system to capture hand motion, apply multi-view hand pose estimation to obtain accurate skeletons, and then combine automatic annotation with expert refinement. OMG-Bench contains 40 micro-gesture classes, 1,272 skeleton sequences, and 13,948 gesture instances. Each gesture lasts from 0.26 to 2.1 seconds, and all samples are provided with frame-level labels. Here is an example of the swipe gesture on the index finger. We define 4 directions, up, down, left, and right, and visualize each gesture using RGB images, 3D hand models, and skeleton trajectories. We further extend swipe gestures to 4 fingers, index, middle, ring, and little fingers. This creates fine-grained categories across both finger identity and motion direction. For tap gestures, we distinguish different contact locations. For example, on the index finger, tapping the fingertip and tapping the MCP region are defined as different classes. The full tap set covers 4 fingers and 2 contact locations. This design makes the task much more fine-grained than conventional gesture recognition. Double tap is different from tap mainly in the temporal dimension. The model needs to recognize 2 quick contacts instead of a single one. Here we show all double tap categories. They are similar in appearance to tap gestures, so recognizing them requires careful temporal modeling. Pinch and release are a pair of opposite motion patterns. Their static poses can look similar, but their motion directions are different. The complete pinch and release set also covers 4 fingers. Overall, our gesture design combines finger identity, interaction type, and contact location. The first 2 properties of OMG-Bench are rapid dynamics and subtle motion. Most gestures last only a few frames, and their trajectories are much shorter than those in macro gesture datasets such as heuristic. Another challenge is high interclass similarity. Some classes are confusing in space, such as ring finger versus little finger gestures, while others are confusing in time, such as tap versus double tap. OMG-Bench also contains frequent same-class continuity. For example, users may perform swipe right several times in a row, which can easily be recognized as one long gesture and makes boundary detection difficult. We further quantify these challenges using 4 metrics: NMJD, MGD, MGI, and SCCGP. Compared with SHREC21 and SHREC22, OMG-Bench has smaller motion, shorter duration, shorter intervals, and more continuous same-class gestures. To handle these challenges, we propose HMATr. It uses a lightweight backbone for frame-level skeleton features, hierarchical memory for historical context, and position-aware queries to jointly localize and classify gestures. We compare HMATr with multiple state-of-the-art online gesture recognition methods. On OMG-Bench, HMATr achieves the best overall performance, and it also generalizes well to SHREC21 and SHREC22. The ablation studies show that frame-level memory, window-level memory, and position-aware queries are all effective. The visualization also shows that different queries capture diverse gesture locations and improve boundary detection. Beyond benchmark evaluation, we also deploy our system on MetaQuest Pro. This demonstrates that micro-gesture recognition can work in a real VR environment with minimal physical movement. Here is an example of gesture-to-command mapping. Swipe gestures can control movement directions, while tap can be used for confirmation. This shows the practical potential of OMG-Bench for future VR and AR interaction. To summarize, OMG-Bench is the first large-scale public benchmark for skeleton-based online micro-gesture recognition, and HMATr provides a strong baseline for this challenging task. Thank you for listening.